another project. What if I use this motor? Well, I'd start by connecting the wires. Okay, the motor is spinning, but I can't control the direction of rotation or the speed. And that's exactly what we are going to solve together today. Hi, my name is Eric from Railwired, and today we are going to explore the principles, wiring and function of the H-bridge. Before we dive in, I want to thank you so much for your support on the last video. The new subscribers and the views have been amazing. If you haven't subscribed yet, consider hitting that button, because here we break down the most interesting parts of the electronics world. Okay. Today's topic is reversing and speed control of DC motors. We achieve this by changing the polarity of supply voltage. Simply put, if we swap the positive and negative terminals, the motor spins in the opposite direction. Let's sketch out a diagram to see how an H-bridge actually works. First, let's set up our positive input. Then, we arrange 4 switches in the shape of 2 eyes. We place our motor right in the middle. And finally, we connect everything to the negative terminal or ground at the bottom. This circuit forms the letter H. When we close 2 opposite switches, current flows from the positive terminal through the motor to the ground. But when we close the other pair, we create a path for the current to flow through the motor in the opposite direction. We have just mastered polarity switching without even touching a wire. Now, we just need some control pins to automate this, and we will look at those directly on the chip I am using today. This is the module I mentioned. One of the most popular H-bridges drivers out there. The L298N. Isn't it a beauty? At first glance, we see SMD's components, capacitors, terminal blocks, and the star of the show, the L298N integrated circuit itself. This chip uses passive cooling, so a quick heads up. That heat sinks gets hot after running for a while. You can see we have terminals labeled out 1 through out 4 and pins like ENA and ENB. This tells us it's a dual channel driver. Think of a toy car. We can use channel A for the left side and channel B for the right side. It's a very practical design. Between the terminal blocks, you'll spot a tiny, inconspicuous jumper. This controls the integral 5 volts regulator. If your power supply is 12 volts or less, leave the jumper in. You connect your battery to the 12 volts and ground pins, and the 5 volts terminal actually becomes an output you can use to power your Arduino. But if your power supply is higher than 12 volts, that jumper must come out. Otherwise, you'll send the integral regulator straight to silicon heaven. In that case, you will need to provide an external 5 volts signal to that pin to keep the logic running. Let's see it in action. I am using a dual channel power supply. One channel powers the module and the other provides a logic 1. 5 volts for the in1 and in2 pins. For this demo, I've set up a breadboard with 2 buttons. Just by using these mechanical components, no Arduino yet. I can freely choose the motor's direction, but that's just the beginning. Let's bring in the Arduino and start the real magic. I've got the Arduino ready and let's see what it can really do. The more observant among you probably noticed the jumpers on the ENA and ENB pins. As long as they are there, the motor is hardwired to 100% power. But what if we remove them? That's right, we can use PWM. Not sure what PWM is? You're in luck. I've already covered it on this channel and you can find the link right here in the corner. Go check it out. In Arduino we divide those 5 volts into 255 values. This allows us to regulate the speed by pulsing the power at a high frequency. Let's add the Arduino to our button circuit, enable PWM and enhance it with a soft start for a smooth takeoff. Check this out. And there you have it. The motor is running perfectly and this tiny chip opens the gateway to endless motor driven projects. Just a quick reminder, if you're working on a heavy duty project, always check the continuous and peak current in the datasheet and choose your model accordingly. I hope you learned something new today. If anything is unclear, feel free to ask in the comments. Thanks for watching and I'll see you in the next one.